Hello students. Today in this video, we will discuss about bacterial growth curve. Bacterial growth curve is a graph of bacterial growth. So it describes different stages that bacteria goes through against the time while it is plated into a medium, and it will show how different bacteria of different genus and different species take different duration for their growth and multiplication. So bacterial growth curve, before I start, I want to tell you in very easy language that this is a graph that is obtained and that describes the different stages of bacteria as it grows. So once you inoculate a bacteria, all of you must have done culture. So once you inoculate the bacteria on a culture medium, that same day or immediately you don't see any colonies. But the next day after incubation, you see visible colonies. So through this topic, I'm going to tell you step by step how those colonies appear. So everything is included under this topic, bacterial growth curve. So first, the introduction. So like I said, when you inoculate the organism into a culture medium, solid or liquid, you will see this. And the different stages that the bacteria goes through are lag phase, log phase, stationary phase, and phase of decline or death phase. So uh, with all these four phases, we have designed the bacterial growth curve. So this is the bacterial growth curve, and you can see on the on the x-axis you have the time in hours, and then you have on the y-axis the number of cells. So this is the four phases that we have just enumerated: lag phase, log phase or exponential phase, both are same, stationary phase, and then the phase of decline. Now one by one we will discuss what are the different phases. Before I start this, let me again tell you that this readings or the time that is required for bacteria is not all same for every bacteria. For different bacteria, they have different times of the lag phase, log phase, stationary phase. So that is the reason some organisms they appear um, they appear overnight. The colonies are seen overnight, and some organisms they take more than a week or up to 1 month for the colonies to appear on the medium. So let's just start. This is the curve. Now we will discuss the individual steps one by one. Here I have lag phase. So lag phase is the first phase. If you can see the diagram in the graph, this line which is parallel to the x-axis is the lag phase. If you look at this graph, you see it is a parallel line to x-axis. That means the time is increasing. So in lag phase, only the time increases, but the number of cell you see is constant. So lag phase is the phase where there is no multiplication that is taking place. This is the time that that is when you have just inoculated the organism into the medium, and this is the time that bacteria takes to adjust itself to the new environment. So you see lag phase is from 0 the time is 1 hour, then somewhere around 1.5 hours it is still the lag phase, and number of cells it's constant. So this is the time where the bacteria do not multiply, only takes the time to analyze and get adjust to the new environment. However, during lag phase we have seen very commonly that the size of the bacteria is increased. So any bacteria when it is in lag phase will have a increased size or bigger size as compared to the normal bacteria. This indicates that they are preparing for the next phase, which is exponential phase, where they will actually multiply and increase their number. So that was about lag phase, where there is no increase in the number of cells. The number of cells remain constant. The organism do not multiply, but definitely you will see the size of the bacterium increases. Now next is the log phase or exponential phase. Both are the same things. So in log phase you see the graph has shooted up. That means the number of cell is increasing exponentially. So after the lag phase, the organism has plenty of nutrients present on the culture plate or in the medium, and it has everything that it requires for the multiplication or the production of daughter cells. So you see the number of cells, how exponentially it is increasing. It is undergoing continuous multiplication, and as the time passes, the number of cells also is increasing in exponential phase. So this is the phase, exponential phase or the log phase. This is the phase where bacteria is mostly active. The most activity of the bacteria, highest activity of the bacteria is seen in exponential phase only, and all the characters, it is also said that all the characters of the bacteria are expressed during log phase only. That's why whenever we do antibiotic sensitivity testing, we inoculate the organism into the liquid medium, and we incubate it for 2 hours. Why that 2 hours is because we want the organism to come into the log phase where it can show its activities, all the character of the bacteria is expressed fully, and so that we can get a correct result. Now, after the exponential phase, where you have seen maximum increase in the number of cells, comes the stationary phase. Okay, here we have the stationary phase. So, after the log phase comes the stationary phase. Now, stationary phase, the graph you can see, it is again coming back to parallel line with the x-axis. So slowly after the log phase, what happens here in log phase is all the nutrients that are present is mostly utilized, and that's why, because that is the reason you are seeing continuous multiplication. That's because they have sufficient nutrients and everything. Most of them by the end of the log phase over here, it is getting utilized. Now as soon as it enters the stationary phase, it doesn't have more nutrients. The nutrients have come down. So what happens, and also along with the nutrients that has the concentration of nutrients that has come down, there is also accumulation of toxic products, toxic metabolic end products. Because when in the log phase organisms are continuously multiplying, at some point they'll start dying also. So somewhat accumulation of toxic metabolites are also there, and the nutrients have gone down. Now the speed or the pace with which the organism was multiplying is become slower. That's why in the stationary phase we have the number of newly formed cells and the number of dying cells equal. That's why you see a parallel line. That means neither the number of new cells that are getting multiplied and formed are more, and neither the number of dying cells are more. Both are equal. Okay, so the number of new cells that are formed by multiplication are just sufficient to replace the dying cells. So here what was the case in log phase is that the number of new cells that was formed due to multiplication was much higher than the number of dying cells, because the multiplication process was very fast. But after reaching here, since the nutrients were depleted and accumulation of toxic metabolites happened, the process of multiplication had slowed down, and you see a slow multiplication here, and this multiplication is just enough to replace the dying cells. So that's why you see a parallel line. There is no increase in the number of cells, it is remaining equal. So this is called the stationary phase. Stationary phase is a parallel line with the x-axis. Next is decline phase. Decline phase or death phase is the phase after the stationary phase, when a phase comes where the number of dying cell has increased the number of newly formed cells. The graph will go down because the viable cells This graph is representing the live cells. Here the live cells was constant, the live cells increases, the live cells is constant again, and now the live cell as compared to the dead cells are lesser, so it's going down. So after the stationary phase, the nutrients that are present is completely depleted and used up. So the number of dying cells are more as compared to the number of newly formed cell. That's why you see the graph that is going down. This is called death phase. So this was your uh, bacterial growth curve, and quickly I'm going to summarize the bacterial growth curve again for you. So bacterial growth curve is a curve or a graph that is plotted against number of cells and time. Time is present on the x-axis and number of cell on the y-axis. So this graph represents the phases bacteria goes through when you have cultured it on a medium. So once you culture the bacteria, next day after incubation you see colonies of bacteria. So in between, what are the different phases this bacteria goes into? That's what we are going to discuss. So the main phases are lag phase, log phase, stationary phase, and phase of decline. Lag phase is the first phase where there is no increase in the number of cells, but there is increase in the size of the cell. This is just the initial period that bacteria takes to adjust itself to the environment. Then comes the log phase or exponential phase where bacteria multiplies continuously and the number of cells increases. Next is the stationary phase. Due to the depletion of the nutrient in or using up of all the nutrient in the log phase, now the nutrients is limited and the number of cells that are produced by multiplication are less, and number of dying cell and number of newly formed cells are same, so that's why you get a parallel line. After the stationary phase, a phase comes called the death phase or phase of decline, wherein the nutrient is completely exhausted and number of dying cell has become more as compared to the number of live cell. That's why the graph is again going down, because this y-axis represent the number of live cells. Live cells is down, going down again, so it is coming back to normal, sorry, coming back to 0. So this is coming, this has taken a curve over here and pointed towards the downside. So this is your bacterial growth curve. Please go through your textbooks and read about it, and if you have any questions, you can always put it in the comment box and you can ask me. I will clear all your doubts related to bacterial growth curve. Thank you so much.